The question of what the Big Bang initiated has been one of the greatest questions in astronomy since Georges Lemaitre's proposal in 1927. The biggest challenge of this question is that we cannot directly observe the Big Bang. However, this has not stopped NASA from using its newest invention, the James Webb Telescope, to seek answers to this challenge. This telescope is designed to capture images extending to the earliest moments of the universe, and no telescope has ever looked this far back before. Therefore, scientists expect that these new findings could completely change our thoughts about space. So how powerful is the James Webb Telescope? And how will this advanced technology provide us with an advantage in discovering the origins of the universe? After 20 years of development and a $9.7 billion investment, the James Webb Telescope was finally launched into space. This might seem like a huge amount, but when we consider how powerful the telescope is, this amount becomes much more meaningful. This telescope will help scientists look back 100 to 200 million years after the Big Bang and gain more insight into how stars formed and how all cosmic structures work. Understanding the Big Bang event better will allow scientists to open a window into the early periods of the universe. So how exactly can this colossal device help us understand the Big Bang? First, you need to understand why the Big Bang is so important. What excites scientists so much about this cosmic event? The fundamental answer is this. The Big Bang is the event that started everything. If you want to understand the universe, you need to understand how it began. Despite what we know about the Big Bang, there are still many unknowns. This historic event is the beginning of everything. Understanding the Big Bang means understanding space science and life. That's why scientists are eager to better understand how the James Webb Telescope will look back so far in time. Let's take a look at our own galaxy, the Milky Way, and the Andromeda Galaxy. Andromeda is the nearest large galaxy to us. It can be seen with the naked eye or with the help of a telescope. However, when you look at the Andromeda Galaxy, you are not seeing it as it is now, but as it was 2.2 million years ago. This is because it takes that long for light to travel from Andromeda to Earth. This is similar to time traveling without leaving our planet. Scientists can look at much more distant galaxies, which means they are looking further back in time. The longer it takes for the light to reach us, the further back in time we have gone. The most distant galaxy discovered so far, GNZ 11, was detected by the Hubble telescope and provided NASA with an incredible perspective. Galaxies like GNZ 11 may appear as mere striking red spots, but thanks to their immense instruments, scientists can see light from 13.4 billion years ago, approximately 300 to 400 million years after the Big Bang. In terms of space research, this, along with Hubble's discoveries, has allowed scientists to observe how stars formed and question some time-tested assumptions about space and stars. However, no matter how powerful Hubble is, its discoveries will not go back more than 400 million years. The James Webb Telescope is far ahead of Hubble in many respects. It surpasses Hubble in terms of what it can see and its immense power. For example, while the Hubble telescope primarily observes optical and ultraviolet wavelengths, the James Webb Telescope will primarily use infrared wavelengths. The reason NASA and the scientists behind James Webb chose to focus on infrared wavelengths is that the light from more distant objects shifts more towards the red. This necessitates moving away from UV and optical to near-infrared observations of distant objects, like the first galaxies forming in the universe. Therefore, the James Webb should not be thought of as a replacement for Hubble, but as a tool that offers us new and different views of the universe that we have not been able to see before. Another reason why the James Webb Telescope is so significant is that it has a mirror that stands 6.5 meters tall. This mirror, consisting of 18 gold-coated hexagonal segments that make up the 22-foot mirror, is almost 3 times larger than Hubble's mirror. One of the most impressive features of the James Webb Telescope is its instruments that allow scientists to deeply investigate the chemical composition of galaxies they point to. Beyond just seeing these newly forming galaxies from Earth, this telescope offers the opportunity to examine them in unique ways. Scientists will try to understand how specific elements form, how dust and gas clouds collapse, and how stars and planetary systems come into being. James Webb has the ability and power to observe the formation process of all galaxies. However, the mission of the James Webb Telescope is not limited to this. Beyond looking at the moment of the Big Bang, the telescope is also designed to search for signs of life. In this long-term research, the atmospheres of thousands of exoplanets in the galaxy will be examined. James Webb will observe the habitable zones around distant stars. Our goal is not to go to these planets and plant our flag, but rather by examining these Earth-like worlds, James Webb will help us understand why and how life arises. Given what the James Webb Telescope can achieve, it's easy to understand why so many people see it as the most important thing NASA has done in decades. The telescope can provide a detailed view of distant planets that could support life and, by looking back in time, fundamentally change our understanding of the universe. It will take some time for us to receive the first images from the James Webb Telescope. However, if you want to see some of the most striking discoveries of the Hubble telescope, don't forget to click on the video on your screen for our next segment. See you there.